Recording this a little later than I was hoping, but this was going to be the first in which case I'm going to start doing Kahoots in the classroom. So be ready for the Kahoot for creating one variable equations and inequalities this Tuesday. Alright, so in this lesson we will create equations and inequalities in one variable using them to solve problems. So, and also if you guys need more visual aid, I always recommend filling in these notes. These just help overall in helping you getting to understand the material. Alright, so let's get into the lesson of inequalities. Alright, so let's take a look here. So the first thing we're going to do is try to figure out sentences. So what I always do here is always ask myself, what am I doing? So he's charging $2 for each person. So that whole idea of each person, that usually means you're going to do 2 times something for each paperback. Sorry, he's charging $2 for each paperback. He earned $10 in sales from hardcover books. It's a $10 in sales of hardcover books. He earned $20 selling books at the yard sale. How many books did he sell? So in this case, what we're doing here is we have this 2 times x, and he's also earning plus 10 times y because these are hardcover books. Sometimes I recommend using variables that kind of make a little more sense. So maybe instead of using x and y, if that doesn't work for you, call it p. And then hardcover book that. And then we're going to say that he earned $20. So let's try to figure this out. He earned that many. How many paperback books did he sell? So he earned $10 in hardcover. Did it not tell us how much he's earning here? So this is a type of multiplication problem. And I just realized it doesn't say each. So he does earn the $10, but it's not for each book. This is for each book, so you have to multiply it. You don't know how much he was selling all the books for, but you know it's like, that's going to be this. So when you're settling this, you're going to settle this as he's going to do 2 times the books plus 10 is equal to $20 overall. So you know it's equal to $20. So that's why you get this right here. It's 2x in this case is a paperback book plus $10, so we get that. Let's take a look at this one. The length of the rectangle picture frame is 10 centimeters more than the width. So if we have this, here's our width, our length is 10 centimeters more than 2 times the width. So we're going to do 2 times the width plus 10, because we're taking the width, multiplying by 2, and adding an additional 10. Find the area. So when we're finding the area, what we're doing is area equals length times width. Well, our width in this case is 2w plus 10, and then we're going to multiply by our width. If we replace these with x's, so let me just replace these. I'm going to get rid of this w and place this w. That's one thing I didn't mention is that we're kind of like substituting different values in. If I distribute this, I get 2x squared plus 10x is equal to the area. And the area of the picture frame is 20. So in this case, we know what the area is. It's not A. They're telling us that the area is 20. So let's take a look at our options here. So we're going to do, we said it was 2x squared plus 10x. So 2x squared. So notice how it's equal? Well, here the closest thing we have similar to that is this idea right here, where instead of making it equal to 20, they're just moving it over. So they're just making it easier to factor later. The next idea we're going to have here is movie tickets. So let me erase everything. So the movie ticket is $20, and the cost predicted to increase by 22%, 2% each year. Sorry about that. Find the cost of the ticket in 10 years. So in this case, what we're doing here is our P, our starting point, or let me do it back in terms that we've done before. So remember, it's gonna keep multiplying. We're gonna keep multiplying everything by 1.2, right? This is how we increase, because it would be something like the price plus the price times 0.02. Well, if we use factoring, we can factor out a p, and we get 1 plus 0.02. So in other words, we're going to get p times 1.02, and we're going to keep doing it by x number of years. Now, the difference here is that we actually know our p. We know what we start with. We know our price at the beginning. So we're going to say 20 is our price, and then this is going to equal to 1.02, and then 10 years, and this is going to be our new price. I'm going to call it N for new price. Well, let's see how they rearrange it over here. So what they're doing here is, oh, instead of calling it N, they're going to call it P, or X, sorry. So instead of calling it N, they're calling it X. So that's basically what we're doing here. You kind of have to figure it out. 20%, or 20%, 2%, I keep doing that. 2% is 0.02, and we're going to have to multiply by the price plus the P. But if we factor this out, if we kind of do distributed property, backwards distributed property, I'll show you how it looks like with distributed property. If we distribute this, that's how we would get this. So what I'm doing is I'm kind of working it backwards. I know it's the price plus the price times 2%. If I factor it out, I get P and then this, which then becomes this right here, this P and that, to X number of years. We're going to keep multiplying it over and over and over and over again for 10 years. So we're just going to use an exponent to show multiplying over and over and over again. So I'm just going to drag this one over here. Submit that. Let me erase this. And we see that we got it correct. So they show it right here, how they're multiplying it a little differently than I did. I recommend drawing pictures if you're having trouble understanding it. They're distributing it. That stuff's fine. The movie price, they don't even explain it, but it's this idea of an exponential. It keeps growing by a percentage. We keep multiplying and multiplying over and over again. And that's kind of what we learned when we were doing geometric growth. So that being said, let's move over here. And we're going to move past the introduction. Like I said, you guys can always watch those introductions. No videos within videos here. All right, so quadratic inequality. So remember, quadratic means it's a relationship that has a square, or it says second power. So we're going to have an x square. So this comes from the idea of quad, meaning the four sides. So even though a square, like a quadratic, sounds like you should say to the fourth power, it's actually to the second power because it's referring to a perfect square. And now we're going to be combining this idea with the Pythagorean Theorem. So just remember the a squared plus b squared equals c squared formula. We're going to be using that again. And this only works with triangles that have a 90-degree angle. Right triangles, in other words. The reason why quadratics are faced with this is we have squares. There's a square in it. So this could be a quadratic. And let's see how they want to do it. So if we think about it, let's think about somebody running off. So Tom and Brady head off in different directions. So Tom's running one way, Brady's running the other way, and they're running this way. So they keep getting further apart, but that distance in which they're getting further apart is this diagonal right here. So we can actually calculate how far they're getting apart by figuring out the change in this direction. So let's take a look. So they both stopped. So they ran, and now we can calculate that distance. That distance is just this. Well, without even getting a measuring tape, we can just figure out how far this person ran and this person ran. So we're going to say that they stop them is 2 miles more than this Tom ran. So this is Tom right here, and the distance is 2 more than what Tom ran. All right, and Brady ran 1 more mile than Tom. So that's why we're getting this 1 more mile than Tom. Brady's running that. So that's where we're getting this equation from. The next thing we should be doing here is the Pythagorean Theorem. So we're going to look at the Pythagorean Theorem here. And what they're doing here is they don't show it. You really should. Is they're foiling this. A lot of people think that you distribute. You do not distribute these. When there's a plus sign there, you are box methoding this. That's how you end up getting this x squared plus 2x plus 1. Same thing for this side with the x plus 2. You box method it and you get this trinomial. And the reason it's a trinomial is because usually when you box method, the diagonals right here add up to each other. The reason being is, I know it should be a plus 2, I'll switch it to plus 2, is this is 2x and this is 2x. They're both x's, so you can add them together. So that's why it's not a quadnomial. It's literally just a trinomial. So that's where we get all this. The next step, we're going to simplify. So you can see that they kind of added all their x squareds, all their x's. They're going to move everything to one side. From here, we can box method or x method it, whichever way you prefer. Some people prefer the x method. In this case, -2, -3. So our goal is to add two numbers together to get -2. But when you multiply, you get -3. So what I'm going to do is -3 plus 1. -3 plus 1 is -2, and -3 times 1 is -3. So this -3 comes from here, and this -2 comes from this -2 right there. This allows me to do x minus 3. That's where I got this x minus 3 from, and x plus 3. So you can use the x method or the box method. I prefer the box method, but I'm starting to include the x method so you guys have another way of doing it. All right, from here, we can see that our answer is either going to be 3 or -1. Well, Tom can't run -1 miles. That's impossible. You can't run negative. I know you can argue he's running backwards, but that's not what we're doing. That wouldn't make any sense. He's running straight. So that's what's known as an invalid solution. So we're going to say that he ran 3 miles. So we can't do negative, so it has to be 3 miles. You have to kind of think of what's applicable. So let's take a look here. So we're going to do this problem. We're going to say Lisa is repairing a piece of fence. She needs to arrive at point A. So she needs to get over here from point B. So she starts here at point B. But the land there is low, sometimes floods. Before she decides to risk it, she wants to know how much distance she'll have if she goes straight from B to, so she wants to know this distance, straight from B to A, instead of taking the path from B to C to then A. Is a right angle. So she's saying that AC is equal to BC plus 21 feet. So in other words, we're going to substitute this in. We're going to say that we're going to call this X, and we're going to call this X plus 21. And she wants to figure out what this is right here. So we have no idea what this is. We just know that it's whatever this is plus 24. So we're going to erase this, and we're going to say BA is equal to, I'm going to call this X plus 24. I'm just replacing all of these BCs with X's just to make this a little easier for me. So now if I want to solve this, so Lisa she'll walk. Okay, so we're going to try to figure this out. So we're going to say x squared plus 21 plus, or x plus 21 squared is equal to x plus 24 squared. So if we do this, we get x squared plus, let's do a box method to figure out this 21 squared. 21, 21, x squared, 21x, 21x. This here becomes, let me pull out my calculator. This here becomes, everything took a while to get pushed over. 21 times 21, 441. Okay, so we get x squared plus, add these two together. I know it's really hard to see. It's 42x plus 4, 4, 1. Oh, that looks terrible. There we go. Fixed it a little bit. All right, and then I'm going to erase this because I don't need it anymore. If you need to relook at it, just rewind. If I move this, I'm assuming this will hopefully bring my drawings back. It did not. Oh, yes, it did. Okay, cool. And now we're going to do a box method for this 24. There's also another formula for this. I don't like giving you guys formulas, but it is kind of how I do it in my head. If you have a plus b, so any number squared, your answer is always going to be a squared plus 2ab plus b squared. I went over this last time. I called it sum of squares, SOS, sum of squares. This is a nice little formula to remember. So in other words, this could be x squared plus 2 times 24 is 48 times x. So we get 48x plus whatever 24 times 24 is. So in this case, our A is x, our B is 24, and what I'm doing here is I'm just substituting everything in. So that's a cool little formula you might want to have written down somewhere. So let's kind of, oh, that's not what I wanted to do. I wanted to do 24 times 24, and that's 476 or 576. So, and it's 576. Now, it looks like it's big numbers, but don't forget that we still have to bring everything over to one side. Let me erase all of this. So, if I think about it, what's going to happen here is I'm going to use a different color to kind of start combining. These x's add up to each other. I need to subtract this 48 x, I also need to subtract this x squared. So this x squared can cancel out with this x squared perfectly. All right. And if I subtract this 48x, I end up getting x squared minus 6x. Now I have to subtract this. Now I have to subtract this 576. So what I'm going to do is grab the calculator again. I'm going to do 576 minus 441, and I'm going to get 134. Now, remember though, this is a bigger negative. So my answer should be negative 135. So I end up getting this negative 135. Now, this is easier, but it's not easy. I need to find a way to get these to add up. So if we do this box method, I should have numbers. Starting to wonder why these aren't closer together. Let me double check my math here, guys. 21 times 21, 441. Okay, that checks out. 24. That checks out. 441. Yeah. checks out. That would check out too. Yep, those would work. All right. I can't think of a single way to factor this out though. What are options here? This factor, so x squared. What's this squared? Yep. Yep. -6. It is plus, right? Yep, it's plus. That's also plus. Okay. Compared to her other way, which is this. I still need to figure out what this is. I can't find a way to get this because the reason why hold on. We're doing a negative. Okay. That might make a little more sense. All right. The reason why I'm having such a hard time is like I can't find two numbers that add up to 6. I'll do that, but one of them's positive, one of them's negative. So there's 6 numbers apart. So the bigger number has to be positive or negative because we have a -6 here. So because we have a -6 here, we want the bigger number to be negative. So when we're thinking of numbers, I'm going to be thinking of numbers that divide this out. So first I'm going to try 5, and 5 goes in there 2 times. Carry the 3, that's 7. That's not 6 numbers apart. So what I'm going to do is I know I can divide this by 3. So if I can divide this 27 by 3, I'm going to divide it by 3, but also multiply this by 3. That's a weird thing. I'm basically just saying I'm going to try doing 15. 15. All right. And now what I'm going to do here is hopefully you guys have a calculator at home. If not, just have one open or keep getting this ready out. 9. Oh, perfect. So that worked out. So this times 9, and I want the bigger number to be negative. So if I think about it, -15 plus 9 equals -6, and we just proved that if we multiply it, we get this -35. So this means our answer is x minus 15, x plus 9 equals 0. So in other words, we have x equals 15 and x equals -9. All right, cool. So from here, what we're going to do is let me erase all the yes. So I'm going to erase all of this because it's all in my way, essentially. All right, so our x is equal to 15. So this is 15. We're going to put 15 here. So she will save. So we have to figure out what's going on. So first option she has is to do this and this, right? So we have x plus 21. We said we can't have negative, so it has to be 15. So in other words, we have 15 plus 21. So we have 51. 30 and 30 is, or 15 and 15 is 30. Plus 21, we get 51. Cool. Now we're going to have to do the other one. The other one, 15 plus 24. So 4 plus 5 is 9. We have 39. So now let's grab a calculator and figure out the difference. How much is she going to subtract? How much space is she going to save here? So we're going to do the bigger number minus the smaller number to figure out how much space she is saving. 12. So she's saving a journey of 12 feet, basically. Not even the distance of this. So maybe she might not want to do this. And it's how much she saves, not how much she's walking overall. That's why they kind of trick you here because they give you the answer of how far she would walk one way and the other way. But Don't let that fool you. It's saying how much is she going to save. What? There's no way. She'll walk blank. Oh, from A to B. So if she walks straight there, this one was straight there, guys. I'm sorry. Straight there, and she'll save 12. I was so busy focusing on it not tricking me here that when I went back to visit this, I was like, oh, whoops. And they can show you the Pythagorean theorem here. This is going to be very, very similar to the unit activity. So I've seen a lot of people mess up on the unit activity, and you shouldn't, because this is pretty much where they get the unit activity from. All right, let's move on. So now we're going to look at a different type of solution involving area. So think of area as length times width. So we're going to say that there's a length here, and this width is less. If it's 110 minus 2 times the length. So I think this is weird how they do it. The area of the length is multiplied by the width. The farmer has 2 times feet, since the barn will act as a side. So the barn's taking up a side here. Okay. So in other words, the way this is phrased, it's phrased kind of weird, but we can think about it this way. All right, so he only has 110 feet. And he has to cover this area and this area. Well, that's 2L. I'm gonna put an L because the other way looks like 21. So whatever this is, we have to do it with whatever's left of our fencing. So that's why we get this. This is how much fence he has. This is how much he's going to use up just from the length. So that's how we figure out the width. So we're going to do whatever's left after the length, plus the length, plus the other length. So all of this, if we add it up, will end up being the 10. Everything would cancel out to be 110. All right. So that's just setting this up. I'm going to erase all of this. I'm sure they're going to want a specific area. So he wants to cover at least, if not more, he wants the area that he's solving for to cover at least 150 square feet. So when we multiply these out, we want it to be greater than or equal to 150 square feet. He probably has some animals he wants to put in here. Honestly, cattle. He wants to put a lot of cattle in there. So that's what's going to happen here. All right, so doing the cattle, we're going to distribute. So we end up getting negative 2L squared plus 110L. What I did was I switched it. I like having my biggest exponent in the front. So when I distributed these, I just moved my L to the front. All right. And then I also want this to be greater than or equal to 0 because that helps me out. So I'm going to subtract that 1500. So I'm going to move this 1500 over by subtracting 1500 from both sides. That makes one side 0 and one this. So now I'm looking at this and I'm like, I want to factor this. I want to factor this by the x method. So what I'm going to do is I'm probably going to factor out that 2, but just to prove it, let's make sure. Oh, we're probably going to do that in the next page, unfortunately. Remember this formula? Because we're going to do it right now. So what happens here is I did all that work for no reason because they're showing it here. So now we get this. They distributed it out. They got this. They got to this point. They factored out the negative 2. And once we factor out the negative 2, we can basically use the x method. They don't ever show how to factor it. It really bugs me. They're just assuming like, hey, everybody knows this. And this is 55 and 750. So a way we can do that is by multiplying. Wait, why is it negative? It shouldn't be negative. We already factored that out. What are you doing, Edmentum? Oh, Edmentum did a typo again. This is a negative. It's supposed to be a negative. I don't know what happened here. So this is a negative. There's a typo right there, guys. So this is negative 25 minus 30. If we add these two together, it gives us a positive 750. So if you ignore their little typo right here, it makes a little more sense. I was looking at it and I was like, that doesn't make any sense. All right, so, and that's when we get our answers 25 or 30. So our lengths can either be 25 or 30, and this should work out. So they're doing this negative positive thing. So they're reminding us a positive. So basically, I always say it this way: if they're the same, it's positive. Same, positive. If they're different, it's negative. Math is racist that way, I guess. I don't know. That's just a kind of good way to think about it, I guess. It's like if they're the same, it's a positive thing. If they're different, it's negative. At least with multiplication. Multiplication is racist. There you go. Let's see here. So now we're going to do this cases. Oh, by the way, I almost forgot. When you divide by a negative, the sign flips over. So right here, what they're doing is they're dividing by -2, which flips over this sign. All right, so now we're going to do both cases. So L can be greater than or less than 25, or L can be less than or equal to that. So there's a range. Since we have to fulfill a certain area, what's going to happen here is we're going to get two different situations, in which case we're getting this. So there's two possible case scenarios. So what we're going to do here is we're going to test it out. We're going to substitute it in, and then we're going to see that the minimum has to be 25 with a width of that. So they're just plugging it in, or a maximum length of 30 in this. So one way I remember these is if you start off with a less than. So if you start off with a less than, what's going to happen is these go inward. You're going to have a minimum and a maximum, and they're going inward. If this was a greater than sign, then you would go outwards. That's the easiest way to remember it. All right, so let's get this started here. All right, so Mia has 50 feet of fencing. So she has 50 feet of fencing for her kennel. She decides to use part of her house as one of the sides of the kennel. So this is very similar to the barn question. So here's her house. Here's the length. Here's the length. We're going to assume these are the same size. So length, and then the width. And she only has 50 feet. So we're going to do 50 minus 2L, right? And she wants the area to be at least 350 feet. So we're going to say 50 minus 2L times L has to be, let's see here, it has to be greater than or equal to 300. Let's do some work here. So we're going to distribute this out. We're going to get negative 2L squared. I only kept this. This honestly really bugged me having the L as the second part, but I'm just showing it as she has 50 feet minus these two lengths. Then I'm going to rewrite it because it bugs me having a variable more towards the right. And then we're going to do plus 50L. And we're going to bring over that 3, so we get negative 3 is greater than or equal to 0. I don't like this negative, so I'm going to factor it out. And I don't like that 2 either, so I'm factoring out that 2 all the same. So this is negative 50. I didn't make the mistake Edmentum did. I'm factoring out that positive. And this is going to be plus 150. And we're going to end up getting this greater than or equal to 0. Now, we want to get rid of this negative 2, so we're going to divide by a negative, which flips over, give me a second here, flips over this sign to less than 0. All right, so let me erase some of this space. Hopefully you guys got this all down. I really wish I could just select a bunch of it and just delete it. Cool. All right, so I got all that. So now I want to figure out negative 50, 150. If you guys are confused by the x method, feel free to use the box method. L squared, 150. This is L. This is L. I'm going to do, let's try negative 30, negative 20, negative 30L, negative 20L. That makes negative 50L. And I can also see that here, negative 20, negative 30. Now, the reason why you want to try negatives, and I knew to try negatives, is the middle number is negative. 2 negatives make a positive, so that's why they gave us that little review. When you multiply, 2 negatives make a positive. But if you have some negatives, and then you get more negatives, you get a bigger negative. So that's how come I knew if I added these two, I get that. So there's a few equations that we might get here. So this also means that we have L minus 20, and we also get this L minus 30. So since the lower one is 20 and the higher one is 30, that means this L is stuck in between because it's a less than. It's stuck in between this 20 and this 30. However, let's pretend that for some reason this is a greater than sign. If you're dealing with a greater than sign, you're diverging, so you would have 2 equations. But I don't want to get us confused. I'm sure we're going to deal with that on later pages. All right, so what we're going to do here is we are going to find all the ones that apply. So the first one that applied was this L minus 2 is greater than this. So that one was our original one when we did the barn. The next one was this one's kind of a trick question because it did not flip the sign over. So that one's there literally just to trick you. This one is fine because they still haven't factored out that. So that one's okay. This is good to go. Let's see another one. This one is, see how these two are very similar, but this one they factor out the negative, so this one's okay. Let's take a look at this one. Greater than that. Isn't that the same thing as this? No, they're doing this backwards. You have 50 feet. This to me just feels better. Don't let that fool you. It feels better because the L's in the front, but it's 50 feet minus the 2 lengths. She only has 50 feet to work with minus the 2 lengths. And then let's take a look at this one. It's less than. That's not true because we haven't flipped the sign. So there's a lot of trick ones in there. I believe those are the ones that are right. And there we go. And you can look at the rewind and do the process I did over here. I really should have used different colors here, guys. I'm sorry. All right, so let's move on. Now let's look at some financial situations we can model with quadratic equations and inequalities. This one involves the rise and fall of revenue and profit. Cool. So what we're going to do here is Amy owns a theater that presents musicals. She charges $20 for admission. The average attendance is this. So this is her average attendance. She also found that every time she increases the ticket prices, it decreases by 20 people. Amy wants to find the minimum admission price that would charge it to receive that. Okay, so what we're doing here is we need to think of it this way. We need to think of it as ticket price. So let's make a ticket price. So it's going to be ticket costs times attendance equals revenue, right? That's how the basic idea here. We're doing ticket costs times that equals revenue. So we're going to say that she increases the price. So we're going to say that X equals number of $2 increases. So for example, if she increases it by $4, X is equal to 2. If she increases it by $8, X is equal to 4. So it's equal to the number of times she does it this way. All right. So it's going to be the price is 2x. So she's multiplying her price $2. Oh, sorry. Her current price. Blah. So what we're going to do here is her current price is $25 plus 2x. So if she doesn't increase the price at all, it's just $25. But if she increases it one time, her new price is $27. But every time she does this, before she increases the price, it's 850 or 8,500. Geez, that's way big difference. But if she increases the price even one time, the attendance goes down 50 times for every time that decreases. This is a 50x. So that's how we're getting this equation right here. Is we're adding $2 some number of times, but every time we get two more dollars here, we're going to decrease however many people buy it. So as things get more expensive, less people are interested, right? Like not everyone can afford theater tickets at like $27, $29, $31. The more you increase, the less. And she wants to get at least, so she wants to get greater than or equal to $243,000. So that's how we would solve this. So let's get into the problem itself. And they're going to break everything I just did down. So ticket price times attendance. We're going to do that. That's how much for increases. That's for that. This is for attendance. It's going to go down for every one of those increases. Now they're going to multiply it out for us. So that's why I kind of stopped because I figured, hey, they're going to box method this for me. And if I wanted to box method this myself, I would do it like this. I would do the 25 2x, and I would do the 8500 negative 50x, and I would just fill this out, and I would end up getting this right here. All right, so let's kind of move on from here. All right, and moving on from there, we're going to do our own problem. All right, so I'm looking at this. I'm like, holy crud. That looks like a bunch of big numbers. But it isn't that bad because the first thing we're going to do here is we need to make it greater, set the inequality greater than or equal to 0. So we're just going to move this over. That's all we're doing. So the first step, they're teaching this us step by step. So they're not, you know, uh, into the frying pan and into the fryer type situation here. They're working this out. So let me use the equation editor here. So, and let my laziness save me a little. Oops, what is going on there? Where did that come from? So what I'm going to do here is I'm going to try to copy this. Let's see if they're nice enough to let me. They are nice enough to let me. Thank you, Edmentum. I almost said GeoGebra. I got done recording a geometry. The only thing I don't like about this is it's not good at copying the exponents. There we go. So now what we want to do is we want to subtract this from both sides, which means we have to subtract it from here. So what I'm going to do here, I'm going to pretend I didn't write that down. Use my calculator. I'm going to do 2,12500 minus 243,600, and I get negative 31,100. So I'm going to get this negative 100. Oh, let me just type it in. I don't know why I'm doing that. I'm going to get this negative 100 control X, control up 2. If you guys don't like doing control up, you can always use the little button right here. Plus 15, 7, 50, plus 2, 1, 2, I'm sorry, plus negative 31, 100 is, and the greater than or less than sign is right here. So this is why I did this in the equation editor for the squares, as well as for the greater than or equal to 0 sign. So that's all they wanted me to do. That was the only directions they gave me. Cool. So then they want us to simplify by doing the leading coefficient. So me, being the lazy person I am, I'm just going to copy and paste this. I'm going to edit my equation. I'm going to delete this. And I'm going to factor out a negative 100. Or they want us to do a leading coefficient GCF. So GCF. So at first I was thinking 100, but this one doesn't end in double zero. So instead, what I'm going to do is I'm going to divide everything by negative 50. I'm going to factor out negative 50, in other words. So this is 2 x control up. Oh no, control V. Control up. 2, I must have hit an A when I hit control. And then plus, I don't know what that is. Give me a second here. Actually, it's negative, because a positive divided by a negative 50 is going to be negative. So we're going to do 1, I was in the calculator, 150, 750 divided by 50. Notice I'm not really using the negatives and positives because I already know how to do the negative and positive thing. I'm just literally doing this. Oh, I forgot my x's. Oh my gosh. All right, and then clear this. I'm gonna have to fix the other problem too. 3, 1, 1, 0, 0 divided by 50. And this one we're doing a negative divided by a negative, so that's gonna be a positive 622. Right, cool. So I am going to accept that as my answer. I'm gonna submit it. Luckily for me, I forgot to submit this one. So I can add my X right now. I don't know where that went. I had it on the original. Super weird. I guess I just didn't hand enter it. So what they're doing here to show that they're factoring is they're kind of doing this whole division thing. Oh, and they wanted to divide it by 50. Well, what you can do, guys, if you're worried about that, is you can always go to this equation, edit it. You can still equation edit it, and it should save. Oh, I almost forgot. I forgot a bunch of things here, guys. Oh, I'm so sorry. 0. And this is going to end up being 2x squared. Oh my gosh. Go up squared minus 315x plus 22. Since we divided by a negative, we have to flip the sign to a less than or equal to sign. 0. We're dividing by negative 50, but that negative 50 there. So it's a good thing I saw that so I could fix my error there. So it's important that you guys don't copy this, but you can fix any of your mistakes or do anything in your own words. All right. Factor to factor the left side of the inequality by grouping. They want you to factor by grouping. I honestly think that is a terrible idea. It requires a really big understanding of how to do this, but I guess that's the best way to do it. All right, so let me show you guys how to factor by grouping. What you have to do here is you have to do 2 times this. You end up getting you end up getting 1244. So now you want to do an X method here with 1244, and you're going to get negative 350. And your goal is to somehow get a number, these both have to be negatives, by the way, that somehow multiply to get this, but add up to get that. So it's a bit of a leap. It takes some time. So let me think here. I'm trying to think of a way. I can't even think of a way to break this up. Because there have to be 2 negatives. Oh, this is a 315. I don't know where I got that 355. That might make it a little easier, but even then, I don't think so. Let me think of factors of this. If I divide by 1 plus 2 plus 4 plus... I'm trying the divisibility rules. It's 11, so I know it's not divisible by 3. Let me try 7. Can I divide this by 7? I don't know the divisibility rule by 7, so I'm literally just going to try dividing it by 7. Why would they make us factor this by grouping? That's terrible. This is a really big number. All right, leading coefficient. So I'm pretty sure, I know I did that right because the answer is right here. So you want to factor this by grouping. Factor the left side by grouping. And then you have an even number on one side. All right, so I need to get an even number on this side and an odd number on the other side. So what I'm going to try to do here, I'm going to try factoring by 5. I factor by 5, I get negative 63. Still don't get an even number. How do we get an even number out of this? Because I need to factor out this 2 somehow. I'm not going to factor by grouping. I honestly think... I wish I could help you guys with factor by grouping, but honestly, box method has never failed me. I'll try 2x here, because this is 2x. squared, and I get negative 315. So I'm going to try some negatives here. This is x. So I'm going to try multiplying it by something with 2. That's going to be too little, I feel. Might be worth a try, though. Negative 2. And this is going to end up being negative 311. Oh, that might be too much. There's going to be too much if I multiply it by 2. I just realized that. Move this over here. And I'm going to try negative 2, negative 311. This ends up being negative 4x, negative 311x. There's our answer. Way better than factoring by grouping. So I'm going to explain how I did it. So using the area method, box method. I didn't realize this was called the area method until way after I'd been calling it the box method for a long time. We get the factors as 2x minus 31 or minus 311 and x minus 2. Therefore, and me being lazy, I'm just going to copy this. Is less than or equal to, where's the less than or equal to sign? 0. Submit that. Solve the inequality for a viable solution. So we're going to grab this, Control C, Control V, Control V, equation editor. See, apparently it doesn't like us doing the equation editor within an equation editor. See, but if you go inside the equation editor and take it, then you can do this. So we end up getting 2x minus 3. 311 is less than or equal to 0. And we also get minus 2 less than or equal to 0. So the first one we're going to get is 2x is less than or equal to 311. The next thing we're going to get is x is less than or equal to, I'm just going to leave it as a fraction, 311 divided by. And over here, we're going to get this x is less than or equal to 2. And remember what I said, one of them has to be a maximum, one of them has to be a minimum. Well, guess what? This is going to be our maximum, and this is going to be our minimum here. I know it says less than or equal to, but remember, we have to deal with a maximum and a minimum because we started off with a less than. All right, so we get that. So our viability is going to be in here. I didn't realize they wanted us to set the range, but I had already set it in words. So the minimum 2. So as long as she only increases it 2 times. So what is the minimum number supplied to get the what is the minimum number of $2 increase? She needs a minimum of $2 increases to reach the desired amount, which is an increase of $4 overall. So she has to increase it twice. It's $4. I think I even said that when I was kind of working this out. All right, what's the minimum number she can charge to reach her goal? Recall the ticket price represented. Oh, I said this in. Oh my gosh, my typing is all over the place. Said this in the last. That's what I get for thinking ahead. Problem $4. It even says right here. So it's nice enough to remind you, like, hey, don't forget each one of these $2 increases is $2. So she has to set it up $4. Did it ask for the maximum? Did it really? This has been a number of price for call that. Oh, is it asking how many people? What's the minimum ticket price number she would charge at this goal? Recall that. I think they messed up somewhere here. Oh, it's $4 increase. $4 increase, which we have to add to the $25. So this price is $29. Oh my gosh. I'm gonna fill this out now. I keep forgetting to read the problems all the way through till the end, causing all mistakes. Let me submit the ones I didn't submit before, which I believe was only like the first one. Literally only the first one. All right. So now we're going to do radicals. And this is probably the last one I'm going to do. I'll finish this off. Well, let's see how much the radicals and inequalities are. So with radicals and inequalities, we have to think if we're solving for a side, we can't have a negative length. So we're going to be talking about multiplying these squares and figuring out the lengths of these squares. So again, we're dealing all with areas. So if you guys are ever wondering, when do I use squares? It involves a lot of area. It involves a lot of multiplying things that you don't know, that you can fill out later on. All right, so if we're doing this, we can figure this out as two different equations. When we get to the squared, we square root, there's a positive and a negative answer. It is important for us to check to make sure we get a viable answer. So we get a positive and a -4. So we're going to check -4. This checks out. This checks out. Why do we do this? Well, what would happen if we get a negative square root? That would result in an I. So if we get an I here, that's not good, because then what's going to happen is this is going to end up being like 5i. So that's why we have to check these. All right, so let's check this out. So first we have to set up the equation. Let's set up this equation. A resident complex has a flower bed. The groundskeeper has decided to increase the area of the flower bed by 4 square feet. So we're going to increase the area. So the area plus 7 feet. All right. If the side length of the new square is 5 feet, which equation does this? So, in other words, this is 5 feet, 5 feet. So, in other words, we get 5 equals the square root of x plus 7, or former area plus 7. The other option would have been 25 equals a squared plus 7. So if we're taking the square root, we would take the square root of everything. So, oh, actually, give me a second. Let me show you guys what I mean. So we have this area, and this area is squared. So if we wanted to figure out the sides, let's pretend we didn't know what the sides was. We have to take the square root of a plus 7. That equals our side. They gave us the side, and this is a 5. I know my 5s and my s's look very similar. I'm sorry. So our answer has to be this, because we're taking this is our new area and the side squared. So we get that. That one was pretty self-explanatory. Moving on. So now we're going to do radicals and inequalities. So if we want a greater than or less than. So when we're talking about this, we're going to be talking about the area of a triangle, it looks like. Let's think about the flower bed. So here's our flower bed. A perpendicular. Let's say it's 3 inches longer than the other. So we're going to say this other leg is 3 inches longer. So we're going to use our a squared plus b squared equals c squared to figure out that hypotenuse. So this is where we can get radicals here. If we're solving for the hypotenuse, we're going to have to take the square root at some point in time. So this is where we get polynomials combined with this. Now let's say we want that length to be less than or equal to 71. She doesn't want that side, that hypotenuse, this length to be bigger than 71. It can be 71. It's okay to be 71, but she doesn't want it bigger than that. All right, so now what we're going to do here is once we solve it, so now model to carry out the answer. So we're plugging in the answer that we got previously and checking if it works. She's seeing if her answer works. So she's seeing if, well, let me try making this 36 and seeing if that'll be okay. It is less than, so it works. We're good to go. I don't know why I did a thumbs up right now. You guys can't see me. So let's finish off this activity. I know this is a long video, so actually, no, I want to finish it while I'm still saying this. So a ladder leaning against the wall, the distance from the foot of the ladder to the wall is 7 meters less than the top of the ladder to the ground. So basically, imagine this rectangle. The distance so we don't know what the height is, but we do know the distance from the wall to the ladder is x plus 13. Create an equation. The distance, create an equation that models the length of the ladder in terms of x, which is the distance between the top of the ladder to the ground. Oh, a ladder is 13 meters long. Oopsie. I was like, wait, that's too much to add. There we go. So we have this, and we're going to do x squared plus b squared equals c squared. So let's get this done. All right, so we're going to do x squared plus b squared, and we have to put the x plus 7 in parentheses because this whole length is going to get squared. That plus 13 squared, and I randomly know that 13 squared is 169. Put that in. I'm gonna do this. All right, so we're gonna be doing this right here. Use the equations you wrote in part A. Find the distance between the ground and the ladder. So we're gonna try to figure out this x. So let me grab this formula here, and we're gonna do a whole bunch of fun stuff. Yay. So let's work this all out. So I'm going to slowly work this out on the side. I'm going to hit enter. I'm going to do x squared plus, I'm going to pretend to do my box method over here. Well, I'm not going to pretend, I'm actually going to do it. I recommend the whiteboard. If you go to the dollar store, you can buy yourself a cheap little whiteboard. Those are really easy to like just erase and do all of this stuff here. I'm going to do that. I'm going to do this. And we're going to get 49. So we end up getting, oh, and don't forget to add your like terms. All right, so if we're going to do this, we're going to get this x squared plus, I already added them, it's 14 plus 49, and this is all equal to 169. Make the smaller x go up to plus 14. I want to, oops, and was there a minimum? I forgot if there was a minimum here. Oh, there is no minimum. We're doing it exactly because it's exactly 13. So what we're going to do here is this is going to be x, and give me a second here. We're going to subtract. So we're going to get negative 129, oh, 120. 120 is equal to 0. We're going to factor out that 2 plus 7x minus 60. So what I did here was I divided everything by 2. Now, or I factored out a 2. Then I divide everything by 2. So, oops, almost forgot my square root there. So 2 divided by 2 is 1. That's why you don't see a number here. 14 divided by 2 is 7. Negative 120 divided by 2 is negative 60. And then from here, I am going to divide by 2. So the 2's cancel out. 0 divided by 2 is just 0. So you just end up getting this. So now we're going to totally box method this. I'm going to erase the previous box I had so I can do another box. So this becomes this x squared negative 60x, and we're going to get this 7 squared here. So notice how this is a negative, so I want a negative and a positive, but since my middle number is positive, I want a bigger positive number. So I'm going to try something like 12 minus 5. So if I multiply those, I get negative 60, but if I add them, more importantly, 12 take away this 5 gives me the 7. So that works out. So I'm going to end up getting this as x minus 5 x plus 12 equals 0, which means my answer is x equals 5 or negative 12. Well, we can't get a negative length. So that means our answer. So hold on. Okay, this is we can't get a negative length. Answer must be 5. So it's going to be 5 meters from the ground. Basically, think of it this way. This is the wall. This is that. This is 5 meters. It can't be negative 12 meters. That wouldn't even make sense. I don't even think it would be able to stand. All right. So what we're going to do here is create a situation, a new situation using the same model. y. Actually, guys, okay, it's not that far. So create a new situation using the same model. I'm gonna make this easy. I'm gonna use a Pythagorean triple just to make this easy. I'm gonna think of something simple, like what is it? I want to say it's 3, 4, and 5. The reason why I know this works is 3 squared is 9, 4 squared is 16, and 5 squared is 25. So let's kind of work this backwards. We're reverse engineering something that we know already works. So we're going to say that a 5 meter, I say meter because 5 feet is very tiny, 5 meter ladder is leaning, 5 meter ladder has, what did they call it? Distance between the base less than the distance. Okay. Has its top 1 meter more has its top to the ground 1 meter more than the. I'm gonna have to rewrite the whole thing. Um, 5 meter ladder. 5 meter ladder is leaning on a wall. The height from the top of the ladder to the, the height from the top of the ladder to the ground. I'm sorry, guys. I'm really bad with words, so you guys might want to heavy inspire your answers on mine or create your own, and that'll probably be better. The height from the top of the ladder to the ground is 1 meter longer than the bottom of the ladder to the wall. And this all makes sense because if we think about it, what's happening here is I'm just saying this, this, and this. I don't think they want us to actually solve this. We're just doing this. This is 1 more than that. So if you add 1, you get the 4. I don't know if they want us to solve it. They just said create a situation using the same type of model. So I'm literally doing that, just doing it with numbers I already know work on the Pythagorean theorem. Oh, and they actually did solve it. Actually, they didn't. They just kind of set it up, but that's fine. So now we're going to do something like this. So what do we, so we have this long equation. So there's a situation where radicals that we want to solve, blah, 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 blah. Suppose the hardest a high schooler can throw is this far. So they're going to plug in our velocity here. Roughly that many miles per hour. If the mass of the ball is this much, which inequality symbolizes the velocity of the ball? Okay, so we're trying to solve for this. Okay, so we're doing kinetic energy. So we're trying to solve for the velocity. So here's what I'm going to do. The velocity is 35. So I'm going to rewrite this a little easier. So I'm going to do k is equal to, well, 1/2, that's basically saying this, divided by 2. half of this is just whatever this is divided by 2. Mass of the velocity. I'm going to call this m. And then I'm going to multiply that by v squared, the velocity squared. We want to solve for the velocity. So what we're going to do here is we're going to multiply both sides by 2. So we're going to times by 2, times by 2. So we end up getting mv squared equals 2k. Then we're going to divide by m, divide by m. So I get m, or v squared equals 2k m. And then in order to get rid of the square root, I have to square root. So I get v squared equals 2k over m square rooted. So I'm going to look for this. So my velocity is 35. Oh, and the picture, the hardest it can do. So the velocity, this has to be less than. The velocity has to be less than or equal to this. All right. So then velocity is less than or equal to, because they can't throw any harder than this. So it has to be less than or equal to 2k over m. We're going to plug in this. So basically, the alligator is not really interested in however fast we're going. So right off the back there, I can eliminate most of these. And then we're going to divide by m, which the mass is that. So our only answer can be this one. So our only choice was really this one or this one. And since the alligator isn't as interested in that, we're going to say this. What? Did I divide by a negative at some point in time? Kinetic energy, 2 times the kinetic energy. We did that. Suppose the hardest baseball throw is this. Let me rewrite this with the inequalities intact, because I think I should have done that from the very beginning. Would have made it easier. The hardest they can throw. Oh, I see. The kinetic energy has to be less than or equal to that, meaning we are going to be interested in it because the kinetic energy is over here. So this has to be less than or equal to that. It can't be any bigger because this is a maximum. So I kind of got those words mixed up. This is the absolute maximum. So if it's the absolute maximum, we cannot get bigger than that. All right. And self-evaluation. Inequality symbols are hard to picture with multiplication being involved. So I'm just saying that when we have multiplication involved, it's a little harder to picture how we want to do this. The way we set this up is the velocity cannot be greater than that. So this is the most it could be. This is the very most. Anything else here is going to be less because this is the tip top most they can get. And they explain it right here. All right, and I forgot to submit something apparently. Let me check all my, oh, I forgot to submit that one. I always forget to submit the first one. So we have like 14 slides left. I did 25. Looks like the next video is just going to be me doing those last 14 slides for rational inequalities. All right.